Hi everyone, my name is Caleb Sykes. This is the Statistics in FRC practical presentation. Just like the other one, this is a new presentation for me also, so if you have any feedback for me, I'd be happy to hear it for how I can make it all better. So again, who am I? I'm Caleb Sykes. I was a student on 2 different FRC teams up in Minnesota, and my qualifications are that I've played around a lot with FRC statistics. And still unemployed, so if you have a job opportunity, you can definitely let me know. Okay, a couple quick definitions here. OPR is offensive power rating. I sometimes call it calculated contribution. When I talk about Ehlo or Ehlo models, specifically I'm referring to my Ehlo model just because I'm most familiar with it. I made up this term that I call Variance Adjustment. If someone knows an actual term for this, once I describe it later, you can let me know, because I feel like there should be a name for it. But what I define it as is it's behaving in ways that increases or decreases risk-reward opportunities for your team. Okay, so how do we calculate these metrics? OPR, calculated contributions, things like that. You should go check out my other presentation for how all those are calculated. But we're not going to spend a ton of time talking about how they're calculated here. We're going to be talking about how you can implement them and use them. Broadly, calculated contributions are kind of like averages, but supposedly they're better because they can incorporate information about the partners on your team. And you know, if you have worse partners and score higher, that's better than if you score higher but have strong partners, because your partners are probably a good part of the reason why you're scoring higher. Ehlo is an iterative strength estimator, and the idea behind it is you gain Ehlo points each match. You gain Ehlo points each match, you do better than your expectations, and you lose Ehlo points when you do worse than your expectations. So it's just tweaking up and down your estimate for how good your team is. Okay? So big question right at the start is, why do we even use these metrics at all? Why would we use Ehlo or OPR or anything? Should we just do scouting instead? And I hear this a lot. And obviously, yes, you should still be scouting. It's not, we're not trying to supplant traditional scouting with these metrics. These kind of metrics are nowhere near developed enough that you can just swap them out for traditional scouting and use that for your line selection. That said, there are insights you can gain from these kind of metrics. And there are some shortcomings in traditional scouting that you can kind of help out with those when you use Ehlo or OPR or things like this. So just as a quick example, so you can be thinking of this, how do you prepare for a match if you're early in the event or early in the season where literally none of the teams have played yet? Like, how are you going to use your scouting information for a situation like that? And you really can't. You could use pit scouting, you know, which is, you know, not super great, or, but you can't, there's no match data to go off of. And sometimes previous events, match video doesn't exist, so you can't go back and look at how teams did in those previous events. And so there's cases like this where some of these algorithmic metrics have some advantages over traditional scouting. Key point here that I want to get out of this isn't to be thinking about which one is strictly better than the other, traditional scouting or, you know, these kind of algorithms and metrics, because neither one is strictly better than the other. They're best used if you mesh them together and find the strengths and weaknesses of both. And to do that best, you need to understand what are the advantages and disadvantages of both, and try to use them in a complementary way. Okay, so here are some of the big name metrics here, and just a quick summary of how I think they should be used. So Ehlo and OPR are the most predictive of any of these team strength metrics. I don't even really think the other ones are worth using for this kind of purpose, where you just get a sorted list of teams from best to worst. In my work, I often use the average of the Ehlo win probabilities and the calculated contribution win probabilities, because the average of those two is a little bit better than either one individually. So they're pretty close in terms of how predictive they are, which is why you can just average them together. DPR, defensive power rating, is it's pretty close to noise usually in most years. It's basically just random. It's so bad that it's not even intuitive to me sometimes if higher or lower DPRs are better or worse. Like, I don't even know which way to sort the list to see which team is better at defense, and there may even be some year dependence on this. Sometime I kind of want to go and take a look at this to verify this, but it's really just a very bad metric. If you remember from my last presentation, there's a linear relationship between calculated contribution to the winning margin and OPR and DPR. And because we have that relationship, if DPR is just noise, we can kind of rewrite this equation as calculated contribution to the winning margin is just OPR plus some amount of noise, which in my opinion makes CCWM basically just a worse version of OPR, because it's got all of the information OPR has, plus just randomness thrown in there. So I don't really like CCWM very much. The last one, not as common, but I've seen it a little bit, is something called winning margin power ranking, or power rating, and that's, in terms of predictive power, it's even worse than CCWM, so that's a really bad one. I won't use that one. Okay, so that's some really broad, high-level stuff. Any questions up to this point so far? We'll dive into some more stuff, but anything? All right, like I said at the last one, if you have questions, you need to tell them to me, because I can listen to myself talk all day. But this is for you guys. So, okay, so let's get into match strategy. How can you use some of these metrics for match strategy? Usually the most important thing people focus on for match strategy is how to get your alliance to score the most average points, or the winning margin, really, if you have defense. And I think that's a really good high-level strategy, and I think that should be the first thing you look at when you're looking at alliance selection. Just briefly here, you can have a whole presentation, and there exist whole other presentations on this, but to me, when I did drive coaching, kind of three things I always looked at were pathing. How do you not get in each other's way when you're on an alliance? How do you set up where you are to avoid running into each other and wasting each other's time, especially if there's a defender thrown in there trying to mess you up. The next thing is to try to get everyone to spend as much time as possible doing what they are best at. There's a really good, if you're familiar with economics, there's something called opportunity costs. So even if you're with, say 148 on your alliance, and 148 is better than you across the board for, in cargo and hatches and endgame and all of those, you need to think about opportunity costs, because even though they're best at they might be better than you at all of these different things, the best way to use the teams on your alliance is to try to get everyone to do what they are best at. So if you're best at hatches, if that's the thing that your team is best at, you should try to do that, and then have robo-wranglers come in and do cargo. Even if maybe robo-wranglers are a little bit worse at cargo than hatches, you want to see what are your trade-offs, because everyone, it's always a choice of what your robot is going to be doing in the match. So yeah, you wanna figure that out, and then yeah, so you get around to endgame, and yeah, maybe your climb for endgame takes 30 seconds, and Robo Wranglers only takes 10. Well, it still might be a reasonable idea for you to do the endgame instead of Robo Wranglers, because you can go and do that, and maybe you're not as good at scoring the hatches or the cargo, so you're not losing much by taking all that extra time to do that. But Robo Wranglers, if they need to go and do that climb, you're taking time away from them to be scoring cargo or hatches or something like that. So I don't know, just think about opportunity costs. Let's see. And the last one, I call it resource management. It's you look at what are the things on the field that there's only a limited amount of. So these are often loading stations, scoring locations, game pieces, where the robots start, where the robots end. And you have to think about those like resources, and before the match you want to try to talk with everyone on your team and figure out how do we split all of these up here to do the best. But yeah, so that's just kind of some general match strategy advice. Like I said, you could have a whole presentation on this, but I think that is the most important thing for match strategy. But the next, I think, pretty important thing that very rarely gets talked about is this made-up term I'm calling variance adjustment, which is what I'm going to be spending a lot of this presentation talking about. And if you can take one thing away from this presentation, it would be that you should be thinking about for your match strategy or for alliance selection or anything like that, you should be thinking about variance in addition to just averages. So what is this variance adjustment? The idea is if you're the favorite in a match, you want low variance. You don't want crazy things to happen. There are less ways for the opponent to win if everything is under your control. On the flip side, if you are the underdog in a match, you want high variance. You want crazy things to happen because there are more opportunities for upsets when things are a little bit out of control, okay? They might not be in your control, but that also means they're not in the opponent's control also. And if you're roughly on equal footing with the opposing alliance, the variance doesn't matter as much. You should really just be focusing on trying to get as high of a score as you can for yourself, or the highest winning margin, actually. So I made a couple of graphs here to hopefully try to explain this. We'll see how intuitive this is. It makes sense to me, but we'll see if I can convey that. Okay, so let's just take this hypothetical game where pretty low scoring game, okay, just on 10 or 15 points or so is the average score. And let's ignore defense for now. Let's just say it's an offensive game, like no one's playing defense or anything. Here are two alliances, and Alliance B in orange here is a better alliance. Their average scores, they're averaging like 12 or 13 points or so, and they could be scoring anywhere from 9 to 15 points or so. And then you have Blue Alliance over here, who's a weaker alliance, who their average score is 8 or 9 points, but they could be scoring anywhere from like 7 to 13 points or so, okay? So you're going into the match, and these are both these teams with their standard strategies, okay? They're just like, hey, we're just gonna go out and we're not thinking about variance, we're not thinking about the opposing alliance, we're just gonna focus on ourselves and try to get the best score that we can for here. Okay, so now what happens if Alliance A, this underdog alliance, what happens if they, well, let's look back at this one here. So the important thing here to look at is this overlap between the two, because these are the matches where Alliance A can upset Alliance B, okay? So most of the time here, probably 90% of the time, Alliance B is winning this match. they have just, if they score just their average or higher, that's 50% of the time they just win the other alliance. The other alliance can't even score that much, okay? And then even if they score a little bit below their average, it's still, you still have to have the opposing alliance be scoring near to their max value to win the match. So this overlap here roughly represents how frequently Alliance A can beat Alliance B. So now let's say Alliance A is like, hey, instead of our standard strategy, we're going to do a high variance strategy. And I'll talk more about what those can be in a second here. But Alliance A says, let's shake things up. Let's make this match more exciting here. And so the first thing to note is if you look at their average is actually a little bit to the left. Their average is actually a little bit worse. And that often happens with high variance strategies or even low variance strategies, is you're sacrificing, you're maybe a little bit below average for your peak, but the important thing to look at is these tails here. It's the probability distribution got flattened out and spread out on the sides. And what you want to see here now, if you look down in this section, you see this area under the curve right here is much larger now. And that's good for the blue alliance. That means the blue alliance now has more opportunities to score many more points. They could score at, now their max is about Alliance B's average points. And there's just more opportunities for upsets to happen here. Now, it's not free, you know, because look at this over here now, there's a lot more chances to have horrible matches also. And that happens with high variance strategies, you know. But if you care about maximizing your chance of winning the match, the weaker alliance here wants a high variance strategy to win that kind of match. On the flip side, Alliance A does not want low variance kind of matches. Okay, so here's a low variance kind of match where instead of having a big range of possible scores, they tightened up that range. So now instead of scoring from 7 to 13, now they're only really scoring from like 7 to 11 points or something. And this is really bad now because now there's almost no chance for Alliance A to outscore Alliance B right here. On the flip side, if we take Alliance B, and let's say they try a high variance strategy, they try shaking stuff up. This is bad for them because now look at how much of this curve there is now for the other alliance to upset them. Yeah, so you get more opportunities for really high scores over here, but your chances for the other alliance to upset you get higher. And here's more what they want. The stronger alliance over here wants some kind of low variance strategy. So again, the peak shifts over a little bit maybe, and you don't get as many very high scoring matches, but the area under this curve right here goes down. You're minimizing the chances that you have your awful matches where the Alliance A could beat you out. So does that broadly make sense what I'm saying here?
So in a way, you're just kind of looking to minimize or maximize that match versus your standard deviation.
Yeah, you're looking at that match in particular. You're not looking to maximize your score necessarily. You're looking to maximize the chance you have of winning. And those are different. And I'll talk about how to make that choice and when it's appropriate to make that choice. But if your goal is to win as frequently as possible, you should be looking to adjust your variance instead of just looking at your average score. Yep. Yeah.
So it seems like this year, for instance, probably a more realistic curve would be if you're the blue curve there. teams that throw defense on the other team, they would actually be altering the other team's variance instead of, I mean, you can control your own, but you can also try to affect the other team's curve more or less.
Yeah, if this is a simplified case, but yeah, if you're here on this blue alliance and you throw a defender on the other side,
it looks like that.
It would look hopefully something like this. If your defender is doing
yours might drop
a reasonably good job, and this actually kind of makes sense. It's this over here is maybe penalties. Maybe you send your defender over there and they get 4 or 5 penalties, and you actually increase. You let the alliance get a higher score than they might have gotten otherwise. But there's more chances for you to really slow them down and shut them down, and give your other offensive robots a chance to get the upset there. So yes, you can certainly affect the other alliance's variance also. Yep. So just kind of be thinking about in some other context, because I'm sure people see this in other sports. So if we look at a couple different pro sports, I made just off the top of my head a list of what I call high variance strategies or low variance strategies. And these usually happen in the last quarter or the last couple minutes of the match is when you're most used to seeing them. So NFL, if you're losing the match, it's getting down to the end, teams start passing the ball a lot. They start spiking the ball to stop the clock. Spiking the ball, on average, is an awful strategy. Why would you ever, you're just throwing the ball into the ground, wasting a play. So on average, that's a bad strategy. If it were a good on average, teams would be doing that throughout the whole match. But on average, it's a bad strategy, but you need to do that to increase the variance. Blitzing on defense is a high risk, potentially high reward strategy. Calling timeouts to slow down the clock. Doing onside kicks. Onside kicks are awful on average, but you got to do what you got to do near the end. Or throwing Hail Marys. Hail Marys, there's on average nothing's going to happen out of it. It's just going to be an incomplete pass or maybe even an interception. But you have to do that if you're down and getting to the end of the game. On the flip side, if you look at you're winning near the end of the match in NFL, you run the ball a lot because it's safer. You let the play clock go down really low. You're eating time off the clock because when there's less time for crazy things to happen. Keep your safeties deep on the field so that the other team can't get a deep pass. You don't use your timeouts. You do squib kickoffs so that the ball doesn't, no one can get a good return for a touchdown or something. How much time do we have? Yeah, we're doing pretty good on time. I'm gonna watch this because I just love this so much, and it's such a great example of a low variance strategy. We'll see if I can pull it up. So let's just watch this and then you can see what happens. Oh, let me put some context here. There's just 11 seconds left in the game. Baltimore in the dark colors over here is up by 1 touchdown, and it's 4th down here. So you're thinking standard strategy, average strategy here is to just pump the ball downfield. But the Ravens do something a little bit different here. So let's watch that, and we can talk about what exactly happens. I probably don't have sound. So I don't know. I'll let it run one more time and talk about it a little bit. But,
brilliant. Good job, Ravens.
Does anyone want to describe what's happening here? What's going on?
Ran clock down, gave the other team 2 points, but not gonna be able to do much else with it.
It's not going to make them win.
No, and then they get a full kickoff.
Yeah. So. So actually, yeah, we can if you get sound, there's actually, the rule here at the end is that the game can actually end on a safety. There's not even a kickoff after.
Mm-hmm.
So they call the safety, and that's the end of the game. And Baltimore wins 19 points to 14. So this is, I just like it so much because it's so ridiculous. And it's not even just the safety. If you see all of these guys over here, they're just like, that guy's got him in a chokehold right there. Look at that. It's like, they're just rampant holding. And they just, and like earlier they like, they have offensive guys, they just like tackle, they just like tackle them. They just throw them onto the ground.
So many flying flags.
And
This guy uses his arm, just holding his arm.
The rest is like.
So like.
I don't have another flag.
Yeah. So on average, this is an awful strategy. Okay, you would, in normal circumstances, you would never intentionally give yourself a safety and, you know, just have your guys just tackling the other guys.
And just.
But it's about the variance here, because if you punt it away, there's a chance the guy on the other side grabs the ball. You can try to prevent as much as you can, but there's a chance he somehow sneaks through and runs in and gets the touchdown, and then you go into overtime, you know? But here, there's no variance here. There's no, the other team can't do anything because they've got him in chokeholds, you know? They're just
Coach is a genius.
grabbing him. And so that's super low variance strategy. You're giving them 2 points, you know, but you take out the last 11 seconds of the games. There's no way the other team can get anything out of it, and you guarantee that you win the match. So that rule they ended up changing some rules so that can't ever happen again. But that was just 1 or 2 seasons ago that something like that happened. But I don't know. I just love it so much. I just love having the guy in a chokehold taking him down. So yeah, and I don't need to go through these, but there's examples in other sports also. I'm not as familiar with other sports as NFL, so I may have missed some, but same kind of idea is when you're winning, you want to eat up the time on the clock, and when you're losing, you want to go do whatever craziest you need to. Like fouling happens in like NBA a lot. You know, you have teams intentionally fouling the other team. And so, yeah, so there's some examples in pro sports. Let me get my mouse back. Okay, so let me open it up for you guys. Let's name some high variance or low variance strategies in FRC matches. What are things you could do to increase or decrease variance in your matches?
Throw out a defense spot.
Throw out a defense spot, that's common, yeah.
That's exactly what I was going to say.
Okay. What else can you do? Yeah.
Citrus is triple level 3 climb.
Triple climb, yeah, triple climb's super risky because they couldn't even do a double climb with that. Like you need both of your teammates to get up on there to get anything out of it. And if one of them gets up and the other one doesn't, you're probably gonna get 0 points on your climb for sure. What else is there?
Just trying to score into the end game, like as late into the end game as you can.
Yep.
Forget the climb.
Eat up some of your safety margin.
Like the littlest margin to make your climb as possible.
Going for some of the higher rocket ship levels.
Yeah, potentially. Yeah, it can be a little bit riskier to go up on the higher levels.
Getting rid of null panels.
Getting rid of the null panels, yeah, that's a good one. It's you increase you could potentially get more points by putting more hatches on, but there's more clutter on the field that could get in your way with the cargo balls. Yep. Those are all good ones. Here's a list of the ones I came up with. There's a lot. If you really get thinking about it, there's a lot you can do. Auto modes right at the start of the match is, you know, if you have multiple different auto modes, if you have an idea for how much variance there are in those. If you're really in a match where, you know, you're up against 118 and 148 together, honestly, throw out your your untested auto mode on that match. You know, the one that supposedly scores 2 game pieces in auto, even though it's never worked before. Because
we've actually done that one.
Yeah.
Those.
Why not?
Because it's probably not going to
Did it
work.
work?
But
No.
but you know, but if it does, you have a chance. You know, you gotta just do crazy stuff again to have a chance of winning those kind
I
of
believe
matches.
it spun in circles. It was the finals, and you might be able to see it. It was in the Dallas finals like the year before last.
Yeah,
We win.
that's awesome.
It's all sparks.
You're trying some crazy stuff.
Yeah, and on the flip side, for low variance, maybe do, if you're the favorite in a match, maybe slow down your auto mode. You know, don't do quite as much in auto, but do it slowly and reliably. Off meta strategies is common, so like the common meta this year was either 3 offensive robots or your 2 best robots play offense and you throw your worst team over to play defense. Sometimes you can just pick some crazy strategy. For example, you can send over your best scorer over to go play defense. It's like, okay, yeah, that's probably not going to work, but you know, you got to go
But
with
if
it.
they're a good defender,
Yeah,
They're
They
good
may
at
not
both.
be-
They might be better.
yeah.
they're a
So
really good defender.
So who knows? You guys mentioned this one for endgame lining up. For high variance, if your normal allotted time is last 20 seconds to go for the endgame, maybe you take 5 seconds off of that for a high variance strategy. You say, we're only giving ourselves 15 seconds this match to climb because we need every second we can out there scoring. But you know, if you're comfortable, you think you're going to win, give yourself 10 extra seconds, you know, instead of 20 seconds, give yourself 30 seconds, just to make sure you get those points right there at the end. Mechanisms, throw on your crazy untested mechanism. For high variance, low variance, don't even touch the robot. If it was good in the last match, just, you know, maybe just tighten some little bolts, but don't you know, add any new mechanism or any code or anything. Aggressive defense often comes up, and not just defense, like specifically aggressive defense. Like you go and you hit them hard, and you go right on the edge of the foul zones. Just do as much as you can to slow them down. Low variance, limited reserve defense. You don't want to risk the penalties. You just want to go and do a little bit, but don't do anything too dangerous. Yeah, and likewise, risking fouls or being super aware of fouls, not to get fouls. Sticking with the same strategy in playoffs for low variance, or you know, you just switch up the game plan to try to throw them off in the second playoff round. So those are some examples, not an exhaustive list by any means, but just be thinking about what can you do in your matches to make things crazier if you're the underdog, or a little bit more reserved if you're the favorite. Okay, so now how do you know when to do this, when to adjust your variance, and in which direction? In the pro sports I mentioned, teams usually only start seriously doing this in the last quarter of the game, the last couple minutes of the game. FRC matches are only a couple of minutes long. So it would be wise for you to go into the match with an idea of how much variance you want in that match, how big of an underdog you are, or how strong of a favorite you are, and to develop those strategies even before you go out in the field. Coaches can change things on the fly, but you get an idea. So the best tool, I think, for this is win probabilities. So before you go into the match, you should use whatever tools you have at your disposal to figure out, are you the underdogs or are you the favorites? And by how much? Also keep in mind what your goals are for the match. Winning is not the only goal in these matches. You can have goals to maximize the number of ranking points you get, to get at least 3 ranking points hypothetically, to get 2 ranking points, whatever. And there's other goals too. But you should take that into consideration. Yeah, RPs versus winning, losing is a big one to keep in mind. Assuming we have bonus RPs next year, but that seems to be we've had 4 years straight of them, so seems like a safe bet. We're going to keep them. So then how do you make win probabilities? Win probabilities aren't the only things you can use, but I like them the best, and they're not difficult to make if you have the formulas. So what I like to do is so there's a couple ways. You can use win probabilities. You can just predict the scores of the match, or you can give each alliance some kind of an overall rating and look at the gap between the two ratings, the two teams. And if you do one of those latter two, I have a formula here to convert those over into win probabilities. So this is the formula that I use. This is actually the formula I use for my Ehlo match predictions, as well as my OPR match predictions. So the win probability is 1 divided by 1 plus 10 to the power of D, which is the difference in skill between the two alliances, or the difference in predicted match scores. And S is some kind of a scale factor. And that's really, for this formula, that S is the only thing you need to figure out. You can, everything else in there, I can talk about why that's mathematically sound, but it's a good formula to use. But S is some kind of scale factor you need to figure out on your own. It can be thought of, it's the difference in skill between the teams required for the stronger team to win 10 times more frequently than the weaker team. Okay, so it's a pretty big gap. To be a favorite by a factor of 10 over the other alliance is pretty big. So for my Ehlo ratings, I use S equals 400. So the sum of the stronger alliances' Ehlos need to be 400 points higher than the weaker alliances' Ehlos. For OPR calculations, I use 2 times the standard deviation of the week 1 match scores. So that was about 34 points in 2019. So if you sum up the OPRs for the stronger alliance, and it's 34 points higher than the sum of the OPRs for the weaker alliance, that alliance will win about 10 times out of 11, like 91% of the time. If you can do this, you don't have to just use those metrics. You can use scouting data or any other kind of data you pull in. Commonly, I see teams use scouting data to make like score estimates for each team or score estimates for each match. What I would recommend would be something in the vicinity of 1.6 times the standard deviation of like week 1 scores. So a little bit lower than for the OPR, where I had it at about 34, or about 2 times standard deviation. This last year, I would have recommended something about like 25 points or so. So if you have the stronger alliance going into the match, and it says, and your scouting data says you expect them to score about 25 points more than the weaker alliance, that's about a 90–91% favorite for the match. But you can tweak it up or down depending on how much you trust your data and what kind of data you pull in, things of that nature. Okay, so you've got these win probabilities now. So now, how do you use them? What I would generally do when I did drive coaching is I would use Ehlo or OPR to make kind of a base match prediction, and later on in the event, when more scouting data is coming in, I would use that scouting data to adjust the prediction up or down, maybe 20% at most. Only 5%. I'd usually adjust it at least 5% in one direction or the other, just based on things I see in the scouting data that you don't have in Ehlo or OPR. But use that to make a general game plan, and then these are roughly kind of the bins of game plans that I would follow. So if we're strong favorites in the match, I use 70%-ish, but you can use anything. you want low variance strategies. So these are the things we talked about earlier. And the other side is you should focus more on the bonus ranking points, because when the match outcome is already kind of predetermined in some sense, there's more importance they should place on the bonus ranking points, because those are still a little bit less determined. Flip side, if you're the underdogs, 30%-ish or less, you want high variance strategies, and you also want to be focusing on those bonus ranking points. If you're probably going to lose the match, but you can make sure if you focus on those bonus ranking points to get those in. And if you're roughly even with the opponents, 30 and 70-ish%, you should just don't be thinking about variance, just be thinking about average points maximization. And maybe focus a little bit less on the bonus ranking points. Like, obviously you still have to consider them, just like you should still consider winning and losing in those other ones. But remember, winning or losing is worth 2 ranking points, and those bonus ranking points are only worth 1. So you want to be careful about sacrificing points to get those bonus ranking points. So those were kind of the general strategies I used, but then obviously you have to talk with your partners and figure out the specifics of your alliance to figure out exactly what you want to do in your game. Okay, there's a pause for that. Any questions broadly about match strategy or variance adjustment? All right, keep on going then. So moving on, let's talk about scouting and alliance selection. So how can you use some of these other external metrics, non-scouting metrics, to help out in your scouting process or alliance selection? The FMS has started providing lots and lots of detailed scoring breakdowns. The robot-specific ones are really good. The ones for, usually these are end-game or auto mobility or auto starting position, or if a robot shows up to a match or not. You can copy these, like, you can get them from First API or the Blue Alliance's API. I also have averages right out of my event simulator, and if you want to copy those right out, those are very good data points that are probably even better than your scouting data, because they're by definition what happened in those matches. So those are really good ones to pull in and look at. For alliance selection, generally, hopefully by the time you get around to alliance selection, you have enough good scouting data to let that be your alliance pick. You don't want to be relying too much on these other metrics. But there are still some insights you can gain from these non-scouting statistics. So what I like to do is compare calculated contributions to scouting data for categories that are the same in calculated contributions and your scouting data. And I roughly estimate kind of uncertainty around a specific calculated contribution at around 10%. So like if it says you score 10 balls per match, that could reasonably be within 9 or 11. And values reasonably close to 0 can really just be thought of as 0. So if it says you score, half a ball per match or negative half a ball per match, that might be 0. So because there's this kind of uncertainty around those calculated contributions, you don't want to get too hung up on differences between those and your scouting data. But the really big differences are where you can maybe learn a little bit more about the game or about how the game is played. So roughly here, this is all made up data, but I have hypothetically here, say this is scouting data for some calculated contribution. So say this is, cargo points or something like this, where you get a distribution of teams, can score lots of different amounts of cargo points. This is according to your scouting data, but according to the calculated contributions, you know, these are very similar. They have a high R² value, but they're not exactly the same. There's some changes between the two. So what do you do with this? You should probably defer to your scouting data, because your scouting data is usually will be superior to the calculated contributions, assuming your scouting process is reasonably good. But what you can do is look at these outlier points, these ones that have a big gap here, particularly on the high side over here. We don't care as much about the lower ones, but for the really good teams, the teams that your scouting data, you know, like this team here, your scouting data says this team is scoring 18 points of, let's say, cargo points or whatever. But according to calculated contributions, they're only scoring like 10 or so. And there are some teams who have the opposite. Your scouting data only says 22 points or something, but the calculated contributions are at like 30. So what do those differences mean, and what do those represent? Well, here are some possible insights you can get out of them. So let's look at, so like 2019, let's say a team has a calculated contribution to their level 3 climb is much higher than a team's climb count according to scouting. So say your scouting data says they climb to the top level 85% of the time or something, but their calculated contribution to level 3 climb is like 98% or 106% or something. So what that might mean is the team is small enough to fit on the level 3 climb with another team, or they have a suction climber that they can climb up after. And what that would tell you is teams, because other teams that just climb, say there's a different team that climbs 100% of matches, okay? But they're big and other teams can't climb up after them or climb up before them. So effectively, they're actually worth a little bit less than a full climb as a team, because you can't, you're blocking out teams who would otherwise be able to climb from getting it. But if you're small like that, even if you don't climb every time, maybe you're still contributing, that's the calculated contribution, you're still contributing about a full climb in every match. And I have examples here for other years also. So auto mobility, say a team's auto mobility rate is much lower than their rate according to scouting. Well, that might be the team is demanding every match that they start in one specific position for auto. And in doing that, they block out other teams from being in that position, and those other teams score less in auto when they're with them. 2017 calculated contribution to the scored gears is less than the number of gears the teams are putting on. That might be they're messy at the loading station. You know, when they go up to the loading station, they're dropping gears on the ground, and it's blocking out other teams from picking up those gears. 2016 calculated contribution to teleop boulders is much higher than 0, but the team has never ever scored a single boulder. Well, that could be a team has an amazing human player that can bowl the balls. If you remember, in 2016, he could bowl the balls all the way over onto the other side of the field, and let your teammates then can pick up those boulders and throw them into the goal, and you increase the average number of boulders that get scored, even though your team never physically picks up a boulder and throws the ball up. So if you look at those differences between like your scouting data and the calculated contributions, those differences can frequently represent things that you would otherwise might call intangibles. These are things that they're not just team X did Y action, so they're worth 1 point. It's more nebulous. It's more, these are things that they're doing, something about that team being on the field is increasing the points of in their matches, even though maybe they're not doing those things directly. It's just something a little bit more out there. And so that's what you can learn from this kind of analysis. And that's what I like to do, is you go look at just a couple of the teams that have really big differences, and you see what are these differences, and what can you learn about gameplay, or what can you learn about teams based on that kind of analysis. So does that roughly make sense? Is there any questions about that? Yeah, so I think it's a lot of fun to go look back at scouting data compared to calculated contributions. And you can often learn things about the game in that kind of analysis, about which things actually have value and which things are, even if a team looks like they're scoring a lot of points, maybe they're hurting their alliance somehow in the process. So I talked about variance adjustment for matches. So let's talk about variance adjustment for alliance selection. Just like with matches, you can use variance adjustment when selecting your playoff alliance. And the amount of variance you want for playoffs depends on which alliance number you are and what your competitive goals are for the match. To figure out your alliance number, you can pull up my event simulator or other event simulators to get a feel for kind of which rank you're going to end up with at the end of the competition. Or you can just wait until qual's over if you're not too impatient. For competitive goals, this is something you need to decide as a team before your event. Here are some options. You guys are in a district system, so generally, probably, you'd want your first event, you want just to get the most district points you can on average. And for the second event, maybe there's enough data out there you can get an estimate of, hey, we need at least this many points to qualify for the state championships, or to be on track to qualify for the Worlds. So determine those before the event, and once you have both of those figured out, then you can go into alliance selection with an idea of how much variance you want. So let's do this again. So just like with matches, what are some characteristics of high variance or low variance alliance selections? What would be the kind of teams you would pick if you want a high variance team or a low variance team?
Well, your high variance team could easily be like the team that can throw up a lot of points, but they break a lot.
Yep.
So, you know,
yeah, that's definitely one, for sure.
A team that you know the robot works too well, but they had, say, a mechanical issue, and their rank is really low.
Yep, for sure. Anyone else? Yeah.
Low variance would say top alliance picking the alliance captain for second alliance.
That happens, yeah, for sure. You pick the team that, yeah, usually if you're seated very high, that means you're some level of consistency usually. So yeah, so there's plenty. Here's some I made up. High variance teams have very high peaks. Low variance teams are consistent performance. You could look at their pit before alliance selections. Are they scrambling around in their pit, fixing and working on things, or are they all, just one or two people tightening some bolts? What do they say to you when they come up to you to try to sell themselves for the alliance? Do they really want you to go watch one specific match of theirs? They say, hey, this is our match where we did everything well. That's probably a high variance pick. And if they're a low variance pick, they'll say things like, we never missed our climb, or we only had this one malfunction for the whole event, but otherwise we were solid. How much they break down, why things break down. These are all things you can kind of look at for high variance or low variance selections. And you can use all this to then, you should incorporate that into your pick. So if you're the number one captain, you usually want low variance because you should be able to steamroll over the 8 alliance and maybe the 4 or 5 alliance and get far into the playoffs based on that. If you're the 7th seed or the 8th seed, you really should probably be picking some kind of high variance teams for your alliance because, you know, they might be a little bit worse on average, you know, but you really, to have a chance of beating those 1 or 2 seeds, you need to have crazy stuff happen and go right for you.
It's often a stereotype, but often the high variance pick will be, let's find the standout rookie team.
Yeah, that can happen. Yeah, and rookies have some variance in there too, just because teams aren't as familiar with them. Teams don't know what they're capable of or what their peaks or their valleys look like. So yeah, rookie teams could be also kind of a high variance pick, or a team that has changed a lot in the last year. So yeah, just keep that in mind for alliance selection, and maybe you can get a little bit further on playoffs. Hopefully based on that. But yeah. Okay. Any questions on alliance selection or scouting? All right. So most of my next stuff, I just have a couple of miscellaneous slides. Some differences between Ehlo and OPR, because they have a couple of differences, so it's interesting to look at. Ehlo is slightly more predictive power than OPR. Not dramatic, because I take an average of them in everything I do. Units of Ehlo can be a little bit difficult to interpret, whereas OPR has units of match points, so it's just a little bit easier sometimes to get a grasp on what differences between teams look like, what do they mean. Ehlo is iterative, so it updates after each match. So at any point in time, a team only has their current Ehlo rating and that's including all matches in their history up to that point in time, and that can be any point during an event or after an event. OPR is calculated all at once right on a set of matches. So usually just a single event is the most common way to calculate OPR. So it doesn't really, a team can have multiple different OPRs depending on which set of matches you look at. So usually they have their first event OPR, they have their second event OPR, they have their world OPR. So it's a little bit, you have to keep that in mind. I have to look at which OPR you're talking about when you're talking about OPR. Fundamentally, Ehlo is an ad hoc mess designed for predictive power. It has an empirical basis. It's based on everything I could find to pull in to make it have the best predictions possible. But I can't really tell you exactly why values have the values they have. It's just, that's how it is because that's what I found when experimenting. OPR, in contrast, has a very strong mathematical foundation and a theoretical basis. It's rooted in statistical techniques, and it happens to be well suited for FRC, but it's not really empirical. It's more, these are things that should work, and then you apply them, and then they work. Ehlo is also zero-sum in season, which means, you know, at the start of the season, every team, the average Ehlo will be 1,500, around 1,500, and near the end of the season, average Ehlo will be around 1,500. And that's wrong in the sense that if you took a team from the end of the season and had them compete against teams at the start of the season, they would be better than those teams. You know, even though the average Ehlos are 1,500s, teams improved throughout the season. And so you don't really get that in Ehlo. So time comparisons with Ehlo are a little bit tricky like that. And the same with across seasons as well. The average Ehlo in 2002 was 1,500, and the average Ehlo now is around 1,500, even though teams now are clearly much better than teams in the past and have more options available to them in terms of, you know, supplier parts and things of that nature that just weren't available back in 2002. OPR doesn't have that. OPR is not zero sum, so if teams score more points, the OPRs will be higher later in the season than at the start of the season. A couple more here quick. Just broadly, how good of predictions can we make with these kind of metrics? Here's a graph of how many correct matches or matches where the alliance with a higher Ehlo wins in each season. And OPR follows a similar trend, maybe 1 or 2% lower. But you can see here it varies from about 2/3 of matches to about 3/4 of matches, depending on the game and the season. 2017 was a record low year for how good of predictions you can make. If you think back to the 2017 game, you can think of just how random it was near the end of the match. Just does a team get a climb or not was the deciding factor of just so many matches. And there was nothing else that was worth nearly enough points to compensate for that, because teams would max out the gears either at 3 rotors or at 4 rotors. You can't score a ton more in auto, and the fuel wasn't worth enough for most teams to go for. So it just ended up being a really, really rough year for those kind of predictions. But most of the other years have been in the low 70s for the past couple of years. This last year wasn't too much different. Yeah, and broadly, these are all just made up based on my observations. But here are my estimates of how good of predictions you could make for FRC. Obviously, year dependent, like we saw on the last graph. It depends on the game, but I think simple algorithms using only match scores, this would be like Ehlo or OPR, things like this. I think those kind of cap out around 75% of how many matches you could correctly predict. If you had more advanced algorithms using detailed scoring breakdowns, I'm looking to expand into this a little bit more, but these get tricky fast. I think you could get up to about 80% or so of matches you could correctly predict with that kind of thing. Likewise, if you have your scouting data and you plug those into algorithms, like predicting match scores, I think that's about 80% as well. And I think a human who watches a lot of matches, has seen a lot of teams playing in these matches, if they were to predict who's going to win or lose, I think that's about 80% as well. So I think that's kind of a spot you can get to in a lot of different ways. You can get up to about that 80% match predictions. I think if you have a human predictions, you have someone who watches a lot of matches and also have a lot of detailed scouting data on hand. Some people might call this like a super scout or something. I think those kind of people in those kind of situations can hit about 85% of matches. And I think that's about the peak. I really don't think 90% plus or higher of matches to predict. I don't really think that's achievable. You know, maybe if you do, 10 matches, you could get 9 out of 10 or 10 out of 10. But if you do an entire event or multiple events, I don't think it's feasible to hit that much higher than that, because there's a lot of inherent uncertainty that goes on in these matches that you really just can't account for. So I think I'll stop there. We're a little bit over time. There's a couple other little things in there you can look at if you want. If you have any questions, you can feel free to talk to me or email me or message me on Chief Delphi. I have all of my work using Ehlos and calculated contributions and the like on my GitHub account, so feel free to check that out. So yeah, that's about all I got. Thank you all for coming. Yeah, let me know if you have any feedback on the presentation.
Thank you.